So what's going on, folks? Welcome to 8th grade science. It's good to have you guys back, and it's good to start teaching you guys. All right, someone has 50 condensers. You have nearly 200. I have no idea what condensers are. Thank you for commenting on my haircut. And guess what today is? Today is my birthday. I'm going to throw this out there, and I really feel a little weird about doing it, but let's try it anyway. Why don't you guys throw out your answers? How old do you think I am? You got 30, 37, 35, 26, low 30s. This is just kind of a game. 83, wow, 75, thank you. Victoria, 40. Wait, Victoria, you said 26 and I was happy with you, and then you said 40, and now I'm like, what is going on? 42. Now you guys are just messing with me. I'll tell you how old I am. I am 32 years old today. Yes, happy birthday to me, and I'm all about patting myself on the back. Yes, I know. It's kind of weird that I announced that, but I figured somebody should kind of say something. I don't want you guys to be like, oh, I missed your birthday or whatever. Don't give me anything. Please don't. I mean, just, yeah. Anyway. Hey, Peyton, Peyton, careful with how you're saying. Or what you're saying and whatnot. All right. So, here's what we ended up finishing talking about. We're talking about the periodic table. And I know I was throwing out some weird stuff for you, but let me just recap, because even though this might not be completely important to you in 8th grade, it will be important to you when you get into physical science and when you get into chemistry. This is what chemistry is all about. All right? So what we're doing is we're talking about the atom, and we're talking about hydrogen and helium and what's in an atom. I'm not going to go into you hardcore with what is inside of an atom right now, because that is a job for chemistry and physical science. But what I do want to talk to you guys about is I'll give you the basics ideas of what is inside of an atom, and then what I'm also going to do is talk to you guys about why there's so much hydrogen and helium in the universe. So what is inside of an atom? An atom has 3 parts to it, 3 main ingredients. You're going to start getting into, yeah, exactly, protons, neutrons, and electrons. Gia, you're going to start getting into this stuff when you hit chemistry. This is, but so I'm going to kind of preview it for you now. But this stuff is still kind of important when we're talking about astronomy as well. So there's protons, neutrons, and electrons. You guys remember? Or this is what I told you before. Now the protons are the positive ones, right? The electrons are the negative ones, and they're really small. They're hanging out on the outside, and they're zipping all over the place. And the neutrons, those are also big things, and they're in the middle, along with the protons. And they don't have a charge. They're neither positive nor negative. They're like meh charges. We cool? Now the protons and the neutrons are the guys that are hanging out in the middle, and there's different amounts of them. Depending on how much protons you have in there, that depends on what element you're talking about. So if we're talking about hydrogen, in fact, we'll look up a periodic table again. If we're talking about hydrogen, then we're talking about 1 proton. If we're talking about helium, we're talking about 2 protons. If we're talking about neon, 10 protons. Cool? Or cesium, 55 protons. Or one of my favorites is berkelium, 97 protons. So the number of protons that are inside of a nucleus, because the atom has the nucleus and it has the little electrons hanging out outside, governs what element you're talking about. So I'd rather have 78 elements than have, I don't know, 77, or I'd rather have 78 protons than having 77 protons. Because if I have 78 protons, then I'm talking about platinum, baby. It's a platinum. That's good elements. 77 is iridium, which isn't as worth as much for platinum. Or if I had 79 protons, then I'm talking about gold, which is Au. Go for it. You can ask me, why is gold Au? And why is mercury Hg? Do you guys know why? Or you guys just don't care? All right. The reason why is because the old school definition of gold was actually aurium. And so aurium, A-U-R-I-U-M, I think it's spelled, is the abbreviation was for Au, but the more modern name is called gold. And so the gold is really just the modern name, but they kept the old abbreviation. Victoria, my video keeps freezing. Does my audio freeze? Yes, the audio freezes. Victoria, I'm recording this archive. I'm archiving this, but if you want, log out and log back in. I'll try not to cover like super important information during the time that you're away. Cool? All right. So the amount of protons governs how much hydrogen, or what element you're talking about. The amount of neutrons doesn't care. I mean, the amount of neutrons doesn't change what kind of element you're talking about. I could have one proton in the middle and two neutrons in the middle. And what does that give me? What element am I talking about? If I had one proton and two neutrons in the middle, I still have hydrogen, I just have a heavier version of hydrogen. Does that make sense? I still have hydrogen, I just have a little heavier version because usually hydrogen has one proton, one neutron, and one electron. So, adding neutrons isn't changing the charge, it isn't changing anything, it's just changing what we call that element an isotope of hydrogen. Yeah, exactly, they're neutral. So it's just like adding extra stuff on there, but it's not changing the element. I understand, Justice, and you can leave at 12, that's fine. I'm archiving this. Make sure you watch the archive because I'm going to finish off the rest of this lecture. Hopefully I'll get through all of it. So anyway, what I did want to share with you is that there's this thing called deuterium and tritium. Now tritium, what element is this? By the way, the plus symbol is the proton and the blue symbols are the neutrons. What element is tritium? What element are we talking about here? Look at this guy right here. Do you guys know? Hydrogen, exactly. We're talking about hydrogen. We're just talking about hydrogen with more neutrons. Because what governs it is the fact that it's one proton. This is hydrogen. This is deuterium, which is hydrogen that we're used to. This is one proton, one electron. This is still hydrogen. This is just a heavier version of hydrogen. Does that make sense? So, what happens in this process called nuclear fusion is we're taking a bunch of hydrogen and combining it together. Now, when I take two hydrogens that have two protons in them, and I combine them together, what ends up happening, what ends up coming out is out of the process is three things. You get helium, right? Because those are the two protons, and it has two of the neutrons that are in there. You get an extra neutron, and you get a whole bucket of energy. Hence, a star being able to burn. This is how stars burn. They take hydrogen and they turn it into helium and a bunch of energy. Does that make sense? So you guys know what hydrogen is, right? In fact, let me show you this video. Hindenburg. This is a pretty cool YouTube video. I only want to show like a 30-second clip if I can. Sure. Let's just do this one. All right, here. All right, here's the Hindenburg. I know it's going to be real glitchy. That's why I'm going to give you the YouTube video. You guys can watch it yourselves. Click on one of those links, and it will bring you to the thing. The Hindenburg. The Hindenburg was a blimp. All right. If you wanted to make a balloon float, you would fill it with helium, right? Because helium is lighter than air. Well, these Germans came about and said, well, dude, helium's still heavier than something else. Helium's is still heavier than hydrogen. Hydrogen is way lighter than helium. So they went and filled up a blimp with hydrogen because it's so light and it would float really, really well. Here's the problem. When you fill up something with hydrogen, pure hydrogen, it reacts very quickly when burned. And they filled up this blimp with hydrogen, and the thing just kind of, boom, when it exploded, killed a bunch of people. It was a terrible, terrible tragedy. That's hydrogen. You folks are already familiar with helium. I mean, that's the safer version of things that float. So we use helium to make things float as well. Hydrogen, helium. Now guess what? Here's the thing that's kind of crazy. Hydrogen and helium make up about all of the matter that's in our universe. And you think to yourself, wait a second, why I don't understand why hydrogen and helium make up the most of the matter in our universe if the things that are around me aren't made of hydrogen or helium. What I'm saying is, of all the matter that we know of, I think that about like 90% of the matter that we know of, that we've seen, is made up of hydrogen and helium. And that's because most of the matter that we know of are found in stars. And stars is pretty much made up of hydrogen and helium in a nuclear process, in the process of nuclear fusion. So that's kind of really what I wanted to talk to you guys about. What is out there? Hydrogen and helium. Yes, of course there are heavier elements. There are gold things. There are silver things, like the ring on my finger. That's silver. But that, in comparison, if you add up all of the amount of other stuff you have versus the amount of hydrogen and helium you have in this entire universe, it would be 90% of it would be hydrogen and helium make up most of it. Why? Because most of the stuff is made up of, most of our universe that we know of is made up of stars. Stars consist mainly of hydrogen and helium. That's how they burn so brightly. They combine two hydrogens, one deuterium and one tritium, and turn it into one helium atom and a bunch of energy, a whole bucket load of energy and an extra neutron. Does that make sense? So that's why the stars burn so bright. If you want the more mathematical explanation, which I don't necessarily think that you guys do want that, but okay, here we go. Presently, there's 74% of the universe is hydrogen, and 26% of the universe is helium. And you think to yourself, wait a second, if I add up 74% hydrogen and 26% helium, isn't that saying that all of the universe is hydrogen and helium? And the answer is yeah, pretty much. But I mean, there's the very, very small percentage that is other elements. That's me. Yeah. So pretty much, almost. I don't know. I think that what they're saying is the theory is that 100% is, but the fact of the matter is maybe 73% and 25% is helium and hydrogen, and then the other elements consist of only 2% of the actual universe. So we are the 2%, because I'm not made purely of hydrogen and helium. Um, why is the helium making your voice high? And I think it's because there's less mass, so it's less dense. That's why you're doing that. All right, yeah, the math version's a little bit, crazy. But anyway, that's kind of what that's talking about. All right, we're going to talk about asteroids because I need to go through these definitions, and I don't want to do a cliffhanger for this lesson. I want to finish it. Asteroids. Asteroids are very big chunks of rock. They are irregularly shaped. They're not circles. Asteroids are not perfect circles. Why aren't they perfect circles? Because they're not big enough to. If a planet gets big enough, then it. Yeah, I think this should be a part of the chapter that you read. But if a planet gets big enough, what happens is the gravity will pull itself into a circle because the circle is the perfect, shape and whatnot. But if a gravity, if a planet isn't big enough, like an asteroid, then what's going to happen is it's going to be all kinds of weird shape, and that's what the way asteroids are. Asteroids are really big pieces of rock. Now, if they're not big enough to have their own atmosphere. If they were big enough to have their own atmosphere, they would be a planet, and not even planets are big enough to have their own atmosphere. They're also not big enough to have their own. They do have gravity because everything with mass has gravity, and these things are really big. They can be a few miles big. They can even be like, I don't know. They can be really, really giant. They could have, like, for example, this asteroid Ida, has a radius of about 15 kilometers, which is about 8 miles. That thing hits the planet, that's a pretty big deal. Now, where are most of our asteroids? The asteroids are mostly found right over here. So here we got Mercury, Venus, Earth, Mars. Mars is on the outside. And then Jupiter is over here. And between Jupiter and Mars, there's this thing called the asteroid belt. There's about 5,000 new asteroids being discovered every month. There's a bucket load of asteroids inside of these things. So there's a lot of these asteroids out there, and a lot of them exist between Jupiter and Mars. Now, what do you think that means? Do you think that maybe one of the slightly bigger asteroids over here will clump together with another asteroid, and then that will make a bigger one, and then a bigger one, and a bigger one, and eventually we're going to get another planet in between Mars and Jupiter? And the answer is no, that will never happen. It's because Jupiter is actually pulling these things apart, so it can never clump together. And the reason why they exist between Jupiter and Mars is because essentially this stuff in the middle is pulling it one way, it's pulling it in, whereas Jupiter is pulling it out, and so it's kind of like gets stuck in this spots over here. Yeah, exactly, it's because of gravity. But don't worry, if you add up all of the asteroids in the entire belt, it only would make up, if you took all these asteroids and put them all together, it wouldn't be big enough to make a planet. In fact, if you took the moon and cut it up into 100 pieces, all the asteroids in our solar system would add up to about 4 of those small pieces of the moon. It's only 4% of the actual size of the moon. So these really big asteroids, although we should worry about them if they end up crashing into us, aren't really that much. Now, there's a few near-Earth asteroids. In fact, there's one in particular that I was a really big fan of, and I was telling you guys, I wanted you guys to look out for this thing. It was called Comet Ison. Did you guys remember? Have you guys seen Comet Ison? Did you remember me seeing posts that I did for Comet Ison? Anyway, there's this comet that we were all really excited. All of us science geeks were all really excited to see, because this comet was going to pass within 800,000 miles of us. That is the closest in recorded history. We would have been able to see this comet in the day, like smack dab in the middle of the day. In fact, if it were, here's what ended up happening. On Thanksgiving last year in November, you know, when you guys were eating turkey, not only was the turkey roasting, but apparently Comet Ison got too close to our sun and it burned up. That's what happened to Comet Ison. It was going around the sun, and as it went around the sun, it went into the sun, and then the sun burned it up. But if it survived its pass by the sun, we would actually be able to go outside and look into the sky and see a comet in the sky right now, in January, in the middle of the day. That's cool. Yes, this comet was going to pass so close to us that it would have been able to be seen in the middle of the day. It would have shined brighter than the moon at night. I was really excited to see this, but then no one could really predict how it will do when it gets close to the sun. And apparently, it got too close to the sun and burned up. Yeah, that's kind of what happened. And so that's why in the plan I was telling you guys to keep an eye out for Comet Ison, because around November, between November to February, you would have been able to see it in the air, but apparently, whatever. All right, but asteroids, asteroids that hit Earth, some could be 5 to 10 meters, which is pretty big. They hit Earth actually about once a year. And we know of about 4,500 asteroids that actually come what we classify as near-Earth asteroids. And they come pretty close to Earth. It's thought that one of the giant asteroids, it's thought that one of the huge asteroids that hit our Earth actually caused the tilt and created our moon. And also, there's about 500 of these asteroids that are actually really big, and those are actually almost a mile in diameter. So hopefully we can find these asteroids. And why would we care about these asteroids and tracking these asteroids and figuring out where they are? Well, the theory goes that if you can find them, then maybe we could stop them or kill them. And that's why I have a picture of this dumb movie up. But that's Hollywood. I don't necessarily know. I mean, if it's our time to go, I think it's kind of our time to go. I'm not exactly 100% sure we can actually shoot and deflect an asteroid. It would be like flies trying to stop a Mack truck. Even if we all work together, it's still a Mack truck. You know what I mean? I mean, even if the thing is only a mile in diameter, the thing is moving fast. Like, really fast. Anyway. Yeah, maybe if we had Bruce Willis to send up there with Ben Affleck, then maybe scientifically it could be possible. But it would have to be Bruce Willis and Ben Affleck. Yeah. And we're not talking about like Bruce Willis from Armageddon. We're talking about like Bruce Willis from Die Hard. All right, anyway. Yes, we need Bruce Willis, Chuck Norris, and Ben Affleck, and Bruce Lee, which is actually the kicker because Bruce Lee is dead, so there's no way we can stop an asteroid. Anyway, going on. However, it's not completely crazy about like Armageddon. I know it was kind of dumb, and it is kind of dumb still. I mean, I hate to say it. But we've actually landed spacecraft on asteroids that pass by really close. And why would we do that? Like, is it just like a challenge? No. All right, so there was this asteroid called 433 Eros. And in 1997, we landed a satellite on there called the Near Shoemaker probe. And it actually landed on the thing. We actually successfully landed one in 2001. There was a Japanese probe. That's the one I think you guys are talking about. And there's one that is supposed to land in 2015. So there's a few of them that are actually going out there and landing on asteroids, and the asteroids provide a lot of information. If we can figure out what's these asteroids are made of, maybe we can actually have Bruce Willis drill into it and then blow it up. So I mean, that's kind of why we're doing this. No, that's not why we're doing this. We're trying to figure out what the universe is made of and whatnot. So that's why. We cool? All right, meteoroids or meteors. Now, do you guys know the difference between an asteroid and a meteor? I'll tell you what. All right, what is it? There's these certain classifications. All right. An asteroid is a really big meteor. That's it. Meteors are just smaller versions. Like they're the size of rocks, just regular rocks. They can even be the size of of dust, or maybe a small car. When you look up in the sky, and there's a few meteor showers that I've had you guys actually go out and look at. Has anyone done that? I know a few of you have actually done that. It was pretty cool, huh? Like when you go outside and you actually look at the meteor shower. People call them shooting stars. They're not shooting stars at all. They're really just dust or meteors being burned up inside of our atmosphere. And when they fly through our atmosphere and they burn up, they create these beautiful, what we call shooting stars. They're not stars. They're little pieces of rock, and they look pretty awesome, I think. Now, I don't know if you can see this picture very well, but let me kind of explain this to you. All right, there's a meteoroid. There's this thing called a meteoroid, and a meteoroid it's some things that are it's pieces of rock that are in space that are smaller than about a meter. So, like a meter stick, I don't know, it's about that long. It's smaller than that. That's a meteoroid. An asteroid is anything bigger than a meter. So is it a meteoroid or an asteroid? Well, it depends. Is it bigger or smaller than a meter? Does that make sense? All right. What is a meteor versus a meteoroid? A meteor is basically when that meteoroid starts burning up in our atmosphere. That is a meteor or meteor. What is a meteorite? Well, a meteorite used to be a meteoroid, and then it started burning up in our atmosphere and then became a meteor, and then it landed on Earth. And as soon as it landed on Earth, we changed its name to a meteorite. You guys get it? So really all we're talking about is the same rock. We're talking about a rock, and if it's a big rock, it's an asteroid. If it's a small rock, it's a meteoroid. If it's a small rock that originally came from space but we found it on Earth, then it's a meteorite. That's it. Oh, and in between it becoming a meteoroid and a meteorite, as it's falling, we call it a meteor. Sometimes things fall and they get really, really bright. We call them fireballs because they're actually fireballs. That's what they are. Why so fancy name for the same rock? I don't know. It's scientific. You need a lot of names. Cool. And then a comet. What is a comet? And I wish I could build a comet with you. I usually do this when I have a face-to-face class. It's not as fun when you do it online and whatnot, but a comet, like if you go down to the Bishop Museum and you ask them to build comets, or if you're on the Big Island, I know that Emi Loa does this a lot, but they'll do like, here's a comet building workshop, and all they do is take dry ice and dirt and like some bleach, I think, or no, they take like some kind of like laundry detergent or something, and they mix it all together and say, ooh, look at a comet. It's not really, it's dirty ice. Well, that's what a comet is. It's really just a dirty ice ball. It's like a yellow snowball hitting you. But then again, if a comet hits you, it'd really do some damage because, a dirty ice ball hitting you at, something umpteen million miles per hour is not so good. See what I mean? So, yeah, it's a dirty ice ball. All right. Here's a picture of a meteorite, and it's actually in 3D, but you can't see it in 3D, so I'm going to move on. What are comets? Comets are giant balls of ice that orbit us, but they have a really, like, the Earth's eccentricity. When we talked about eccentricity, do you guys remember what the Earth's eccentricity was? Yeah, it was actually 0.17. It's really small, and the eccentricity tells you how much of a an oval we're talking about. If it's a high eccentricity, we're talking about a super oval. If it's a low eccentricity, we're talking about basically a circle. If it's got zero eccentricity, we're talking about a circle. So this is a comet, and that's actually a real picture of a comet. Comets have tails, and here's the thing that's interesting about them. Comets' tails don't point in the direction they're going. Did you know that? Comets' tails actually point in the direction away from the sun. So if a comet is going towards the sun, its tail will be pointing backwards. But if a comet is going away from the sun, its tail will actually be in front of where it's going. It will look like it's a car driving backwards. Why do you think that is? The light? Can't remember why? Well, I'll tell you why. Because the sun creates this thing that we call solar wind, and it's really just a convection current. It's hot, pushing away from the colder stuff. And, the solar wind pretty much pushes away from the sun. So the direction that the tail goes is away from the sun, regardless of how the comet is traveling. The tail is always going to be pointed away from the sun. Or I guess maybe the head of the comet is always pointing towards the sun, and the tail is always pointing away from the sun. Cool, huh? All right, where do the comets come from? Well, they come from this place called the Kuiper Belt. And I know that looks like the Kuiper Belt, but it's actually pronounced like viper, the word viper, it's Kuiper. It comes from the Kuiper Belt, and let me show you where that is. So I showed you this picture, right? This was Mars and Jupiter, and here's the asteroid belt, right? Are you guys confused? I'm really just talking story with you guys about this stuff, but are you guys confused? Okay, all right. There's a thing called the Kuiper Belt. Now, I showed you where the asteroid belt is. Here's Mars, here's Jupiter, and the asteroid belt is within that. If I take this orange circle, and there it is right here, and I zoom out a little bit, the Kuiper Belt is actually way out over here. It's on the outside of Neptune. Cool? And this is where a lot of the comets come from. Sometimes comets take maybe 50 years, 20 years to like we see one every 50 years or 20 years or whatever. And sometimes comets take like thousands of years to come and for us to see it. Now, what's cool about the comets is, let's see, the comet, the one that you guys said that was fake, this was actually a comet called Hale-Bopp. Have you guys ever heard of that one? Yeah, this one was in 1997. And actually, I think that was really interesting is, let's see, in 1997, I was a freshman or a sophomore. I was a sophomore in high school, so I was a little bit older than you were in 1997. I was a sophomore in high school. Now, what was really interesting that I found out about this is I remember when the Hale-Bopp comet came by in 1997, and there was a bunch of people that died. And you guys are like, what? And I can't remember exactly what it was. I got to look up the article. It's kind of crazy. What happened was there was this cult, this like religious cult that says Jesus is on the back of this comet. And when he comes, we need to kill ourselves so that we can go with him. And then they like lit themselves on fire. when the Hale-Bopp came. It was crazy. I remember seeing this comment when I was a kid. I actually went outside and looked at it. It was awesome. It was awesome to show, but it made people do crazy things. That's how I remember this comment. This is the Hale-Bopp comment. And the Hale-Bopp comment comes from the Kuiper Belt. Now there are comets that come from very far away, and we actually call that the Oort cloud. The Oort cloud is really far. So something that comes from the Kuiper Belt usually has a period of about 200 years or less. So every 200 years you can see these at the most. For the Oort cloud, those things have, periods of like 50,000 to 100,000 years, or like thousands of years, or even millions of years, and that's coming from here. Like if we're here on Earth and we zoom out and we can see the Kuiper Belt. Here's Neptune. Can you guys see that? And you zoom out some more and you can see the orbit of Sedena. And then you zoom out so that this circle right here, this small little circle, is this thing right here. The Oort cloud is way out here. It's this cloud of asteroids, or cloud of comets that, that there's a whole bunch of things hanging out there. So anyway, that, my friends, is comets and asteroids and astronomy. Next week, I'm going to talk about, what are we going to talk about? We're going to talk about how stars are formed, and we're going to get more into like the different types of galaxies, spiral galaxies, and all of that kind of stuff. So I hope you have fun doing this stuff. And I'll tell you what, some of you have brought up to me that the reading assignment that I assigned doesn't match up with the questions. And the reason being, I'm sure that this is the reason, is because I made the questions based off of an old reading, and I bet you that the company that I told you to go and read changed the questions on me. So here's what I'm going to do, is I'm going to rewrite the questions and base them off of, I'm going to rewrite the questions and base them on the current reading that you guys have. And that way you won't have to reread anything. You can just read it and base that. But give me a heads up. Was the reading anything like what I was talking about? What I've been talking about? Jenna, was the reading? Did the reading have like things? Yes, this assignment will obviously be pushed back. If I change it like on you, then I'll give you another week to do it. All right. But I mean, the reading was kind of close to what I've been talking about, right? It's not like talking about like plants, is it? All right, cool. Then I'll change the questions so that they make sense. Yeah, I'm going to do it within an hour. And I will make sure to email everyone. Yeah, it's going to be due, I don't know, do you guys think a week would do it? Cool. I'll give you a week to do it. Sound fair? All right, folks. No, it's not that big of an assignment. All right, I'll see you guys later.